So open up your review. Let's go ahead and do the last few little pieces that I would like to do for the test. Okay. So I want to now look at, let's take a look at, let's do F. Okay, so we're going to do F. I do need it like some paper. So let me add a page here. So we are going to do the verification 25F. Because we haven't done one where we have to get common denominators, and I believe there's one on the test like that, okay? Okay, so if you see this problem and we want to verify it, remember the most effective way to do this verification is to hold the side that looks the easiest. So I really think that that seems to be the easiest. Now remember, you can keep in mind that that is 2 over the cosine. So, you know, that's kind of what we're shooting for. Because as soon as we get to that step, we can then change it to a 2 times a secant. So that's kind of what you should have in mind as to what you're shooting for. Now we're going to manipulate the left side, and the reason I wanted to manipulate the left side is fractions can be combined if we have common denominators. So one of the keys to this, so that you don't mess up the algebra, is put anything that has more than one term in parentheses. So that would be my first suggestion. Put that 1 plus sine of x in both places in parentheses. Now I'm going to write that same thing down below. I'm going to separate them a little bit so I have a little bit of room. So you'll notice I've just kind of given myself some room. Now, to get a common denominator, any factor that appears in the denominator of the first fraction has to be in the second, and vice versa. So this one does not have a cosine because the first one has that in its denominator. The second one needs a 1 plus sine because it doesn't have it in its denominator. So that's our first step. Now, since these denominators are so very different, multiplying them through is not to your benefit. Keep referring back to our almost answer. Our almost answer is 2 over the cosine. We want this cosine to stay separated. So my suggestion for our denominators, just leave those pieces separated. Here's the time I'll multiply them. I will multiply them if they are conjugates. Like if one was 1 plus sine and one was 1 minus sine, I would probably multiply them. But since they are not conjugates, not good, not anything, you know, not reciprocals, nothing great about them, just leave them, okay? But we do need to multiply out the tops. Now let's talk about how we do that. You have to follow rules of algebra in this process. You might recall in Alex, it kept saying, what are the reasons you did that? And sometimes it would say, because of the rules of algebra. So this 1 should distribute. This sine of x should distribute. And then these 2 we just multiply. So let's get our numerators all ready to go. So we're going to get 1 plus the sine plus the sine plus sine squared plus cosine squared. Okay, so that's what we got there. There's some things that are now happening in our numerator. Does anybody see any like terms that can be combined? Yeah, these are both sine x's, so that is 2 of those. Anybody notice anything else?
Sine squared, cosine squared.
Yeah, that's going to happen sometimes for these. You might have noticed that pattern, that a sine squared plus cosine squared appears in the problem, which is equivalent to 1. Now, keep referring back to our answer we're searching for. We're searching for 2 times the secant. So we needed 2 to appear. What like terms have now appeared in this section so far of the problem?
1 plus 1.
1 plus 1 is just a number. Now this 2 right here is a factor multiplied by the secant. So my suggestion would be to factor that 2 out. By just taking that step to remove that 2, anybody notice now something that magically happened?
1 plus 1. 1
Yeah.
plus sine of x cancels.
Yeah, the 1 plus sine of x cancel out. We are left with 2 over the cosine of x. The reciprocal or flip of a cosine is a secant. And so our final answer is 2 secant of x. So that's a great example there. So please expect that on the verification ones, you can't do anything more than verify, and you'll take a picture of your work. So expect, as you go through this process, have a sheet of paper sitting next to you, take pictures as you go. You can split screen your iPad if you want, open up the Google form on one side, and then on the other side, you could have like a notability page and you could screenshot that. That's okay too. But it will be asking you as you go. If you hit, as you're going through the process, if you hit to submit a picture, you can get right into your camera roll, or you can get to the camera. So if you just tap on, like, maybe it says browse, I don't remember what it says, but you can find those things right on your iPad. Do we have any questions about that verification? Are we good for that one? Okay, so that's an important one to know. I would like to do, I don't want to do 10. We've skipped, I'm sorry, 10, I saw the 10 there. 26D we've skipped. But I would please like to do G instead. So this is an equation one. Please, we're going to do 26G. Okay. Now 26D is solve this equation. So let me kind of show you what I would do. If you do a U substitution, and you let U equal the only trig function we see, and then we just solve it like we solve an equation. So we would add 9 to both sides to get that U squared by itself. Then we would divide through by 9. Now, we would inflict a square root, but what do we have to remember goes in front of a square root?
Plus or minus?
Plus or minus. So that is plus or minus 1. Now, only once you have solved for your variable do you put the trig back in. Now, my brain doesn't go to secants very easily. Secants and cosines are reciprocals. So I would flip the numbers you see there, and I would think cosine. So what is the reciprocal of 1? 1. So that's a great one anyway. So I'm really going to think on the unit circle. We're only looking at unit circle values from 0 to 2 pi. Where is the cosine positive 1? Where is the cosine negative 1? There are only one spot on the unit circle where it's positive 1. That would be at 0. There is only one spot on one flip around our unit circle where it's negative 1, and that's at pi. So that's a nice type of equation that you might see.
We also put or 2 pi?
The interval has a bracket on the 0, but it has a parenthesis on the 2 pi. It's 2 pi is technically correct, but they don't need you to include that because
Okay.
0 lands us in the same spot. If you did, it's not a big deal. Okay, so that's an equation I wanted to talk about. Now, let's see here. I think we're going to go backwards just a little bit to some of, okay. So I wanted to talk about some angles of elevation and depression. So go back to the section, and let's do 18. Let's go backwards, please, and let's talk about 18. Okay. So there are going to be a few where you're going to have to set up your triangle. These are right triangle SOHCAHTOA type problems, so don't expect that they're anything more than that. They're pretty basic and straightforward. If you look, let's take a look at what it says. It says an engineer erects a 90-foot cellular telephone tower. So we're going to have this tower. This tower is 95 feet. It says find the angle of elevation to the top of the tower. So let's make a triangle. I'm really good at triangles. From the point on the ground 70 feet from its base. Round your answer to the nearest 100th place. So we're looking for that angle of elevation. Now remember, an angle of elevation is always from the base looking upward. It is always from the bottom looking upward, okay? So if we set that up, again, if you're doing a SOHCAHTOA type problem, you should label the sides you're given, maybe label what you need to find, all that good stuff. So this is opposite our angle. We can see that by it's just across from it. Attached to it, but not the hypotenuse, is our adjacent side. So our trig function that uses a opposite and adjacent is our tangent, because we know that the tangent of theta is opposite over adjacent. So let's just set that up. We know that the tangent of theta is our opposite 95 over our adjacent of 70. Now, we are looking for the angle measure. That is the only time you hit the second button or the inverse button on your calculator. So make sure your calculator is in degree mode. We're going to assume they want degrees. And if we round it to the nearest 100th, that is 53.62 degrees. So the only time you're ever going to hit that second button on your calculator is if you are converting to angle measures. Okay? Otherwise, you just hit the flat out tangent, cotangent button. Okay? So that is that. Okay, let me go back to the word problems. I think that's all we need to do, because I didn't do any of the ones where we have like a nested triangle. Okay. I didn't do that. I didn't do that. Let's see if I want to do any of those. Give me a second. I'm just making sure we cover all the bases here. Let's do 40. So we're going to do 40. I think we could do that one without a problem. Okay, so let's look. It says to approximate the length of a marsh, a surveyor walks 420 meters from point A to point B. Okay, so we know that this, based on that information, is 420 meters. Okay. Then they turn 75 degrees. Now that's here. Be careful with that. and walks 220 meters. So that's that. To point C. Approximate the length of, we're going to call it Y, I don't know. We can call it little b. It's across from B. Let's do that. Let's find little b if we know all of the information that we're given. Now, we need an angle inside. You always need three pieces to either use SOHCAHTOA, law of sines, law of cosines. Right now, we only have two pieces of our triangle. We need a third. But let's go back to geometry class for a minute. That appears in this class. That's a straight line. A straight line has how many degrees in it? 180. So if this is 75, we know that the angle inside the triangle must be supplementary to that, or this is 105. So using some logic there, we now know three things. Okay? So we need side B. So it's not a right triangle. We can't use SOHCAHTOA. We don't have an opposite pair. We can't use law of sines. So the only thing left for us to use is law of cosines. So we need to use that b squared is a squared plus b squared minus 2ab cosine of, I sure did not set that up right. I'm so sorry. Let's start again. b squared equals a squared plus c squared minus 2ac cosine of angle b. Okay, here's how I knew it was wrong. In the law of cosines, these two work and are matches. They're opposites. These two are the other sides. So that's how I knew I was wrong. So sorry about that, but we got that fixed. Okay, so now let's plop the information into the problem. So this is 220. This is 420. So this is going to be 2 times 220 times 240. And this is going to be the cosine of that 105 degrees. Okay, so all I've done is I've taken the information and I've plopped it into the problem. Now be careful when you do that. Now what's great about this one is because this will just magically multiply everything together, it's not as tricky as when you're solving for the angle. So when you're solving for the angle, there is a problem, and that's 420. I wonder why your faces were like, what are you doing, Mrs. Hall? How about that's 420? Okay, so our sides were 220 and 420. There we go. That's a little better. Oh, anyway, so we find that b squared is approximately a very large number, 2,272,000,000. It is not. It's 272,000. I'm sorry. I'm trying to look at something that is so tiny on my iPad or on my MacBook. I can't see that number. Anyway, that's the number. Remember, we are taking the square root of that. Now, remember, for this, it is just a length. There's no negative that we need associated with it. So we just take the square root of it. And the length, if I can read it, is 522.14 meters. Now, we can do the same trick with this that we have done in the past. 105 is an obtuse angle. It's more than one, or it's more than 90. It has to be the largest one. So since that's the largest angle, this number here should be bigger than the other sides. It's bigger than 420 and 220, so odds are we did it correctly. Okay, so that is an application of the law of cosines. Now the last thing we got to talk about, I know you're sad about that, but the last thing we got to talk about is a little bit of vector stuff. I didn't put much in the way of vectors on the test, but sometimes vector stuff can be really, really nice. So let's just now look at some of the vector stuff we see here. So I would like do 43 together. So it says, find the component form exact values of vector v given its magnitude and angle it makes with the positive x-axis. Okay. So what they've told us is that vector v has a length of 2, and it's at the angle measure 45 degrees. So we're going to start with A. Remember that our A component, or x, if it was rectangular components, it would be x, is always the magnitude, we'll call it r, times the cosine of theta. B is always r times the sine of theta. Okay. So in this particular case, our A is going to be 2 times the cosine of 45. And this one's going to be 2 times the sine of 45. Now the reason they say exact values is because they are going to be unit circle. They are going to be unit circle values. That's why they say that, okay? And so this would be 2 times the square root of 2 over 2. This one will be 2 times the square root of 2 over 2. So our x component, a component, however you want to put it, is square root of 2. Our y is square root of 2. This particular vector v in part A is just square root of 2, square root of 2. So it's just using the fact is if we wanted to use a point to get there, we could use the component square root of 2, square root of 2 would land us in the exact same spot as going on the 45-degree line out to the second ring. So that's something that's very, very quick. So nothing too crazy there. So then let's do B. So that was A. So the x component, or the A component for B, would be 9/8 times the cosine of 150. And B is going to be 9/8 times the sine of 150. Now that's just a matter of knowing your unit circle values. Cosine of 150, at 150, that's the 30-degree reference in our second quadrant. So the x is negative square root of 3 over 2, the y is 1/2. So if we use the x value, that's 9/8 times negative radical 3 over 2. So this one is going to be 9/8 times 1/2. To multiply fractions, just multiply tops with tops and bottoms with bottoms. Unfortunately, there's not a lot we can do. The top is just going to be negative 9 radical 3 over 16. The second fraction, the top will be 9, the bottom will be 16 again. And it's very common that they'll end up having the same denominator and different numerators for those. Not always, but it's kind of something that does happen. So finding your x and y components is not anything too crazy for those, okay? So that is 43. Let's talk quickly about 45 and 46, maybe 47. Okay, let's go and look at 45. It says, represent the complex numbers graphically, then write the trig form of the numbers between 0 and 2 pi. So 4 plus 4i. This is your real axis, so the x-axis represents your reals. This is your imaginary x-axis. So you're going to go 4 to the right, 4 up, you're going to put a dot. Now, if you wanted to represent that as a vector, you could do that. That's it. That's how you graph them. Now, let's talk about putting them into the trig form, okay? We have to find r, and we have to find theta, because the trig form shows the r and the theta. Okay. So let's find the r. The formula is just Pythagorean theorem. It's just its length. That's just a squared plus b squared. So in this case, you don't use the I. That's just 4 squared plus 4 squared. 16 plus 16 is 32. That's just the square root of 32, which 32 is 4 times 2. So it is going to be, it is not. It is 16 times 2. The square root of 16 is 4. I jumped ahead in my brain a little bit there. Okay. Now, theta. The formula you want there is the inverse tangent of b over a. It's the y over the x. The x is represented by a. The y is represented by b. So that's just the inverse tangent of 4 over 4. Now, the tangent is equal to 1 at 45 degrees. Specifically, just note the quadrant you're in. We are in the first quadrant, so it is exactly 45 degrees. Now, they like using radians, but I don't care if you use radians or degrees for me. Here is the answer. Your trig form, you are just going to use r. If I can draw here. You're going to use r cosine theta plus I times sine theta. You're just going to plop the r and the theta in. You're just going to plop the r and the theta in, and you're just going to leave it. That is the trig form. What's great about the trig form is the trig form, if you did multiply it, should go right back to its original form. The trig form just shows you the r and the theta. That's the job of the trig form. So you just plop those in. So that's 4 radical 2 cosine of 45 plus I times, that needs an r there, r, times 4 radical 2 sine of theta. You can also write it just with the r in front of the cosine and the sine. I've seen it written both ways. So you can put the r just in front of both things, or you can just put the r in front of a parenthesis. I don't care how you do it. Okay. So that is that. Let's now jump to 46. Do we have any questions about 45? We're just going to do that. And we're going to do one of these, so let's do this last one here, and maybe we'll do 47. I think we have time for that. Okay, let's do 46. In this particular case, we know the r is your first number, the theta is your second number. And we use what we know about x's and y's. The x is always related to our cosine. The y is always related to our sine. So it's just as easy as saying that the x is r cosine theta. We kind of saw that in the last problem. We called it a's and b's when it is in complex form, but it's all the same thing. And in the notes when we were doing some of, I don't know if it was, I think it was maybe 10.5, there was a graphic that showed you how to move back and forth between all of them. That's a good resource to look at. And then y is going to be r sine theta. The x is always related to the cosine. The y is always related to the sine. We have learned that again and again and again. So let's just find those values. So our x is going to be 4 times the cosine of 5 pi over 4. Y is going to be 4 times the sine of 5 pi over 4. Now let's talk about the point 5 pi over 4. 5 pi over 4 is in the third quadrant. It is related to our 45, but they're both negative. So it'd be negative square root of 2 over 2, negative square root of 2 over 2. So just plop those in, and we're going to find what we want. So this is going to be, x is going to be 4 times negative square root of 2 over 2. Y is also going to be 4 times negative square root of 2 over 2. They didn't ask us to do the x and y, I'm sorry, but so we don't really have to do then 47. I'm doing what they ask in 47 for 46. We'll draw it too. Okay. Anyway, so our x, y, just reduce those down. 4 is divisible by 2, so you just get negative 2 radical 2, negative 2 radical 2. And that's it for that. Now let's actually graph it. For polar, you're going to find the rings. So we're going to go on the 4th ring. I make very pretty circles, don't I? We're going to go at the 5 pi over 4 line, and we're going to go out to the 4th ring. Polars are great to graph. They're you know, be careful if the front value is negative. You go backwards on the line instead of forward from center. So that is your last time, except for juniors. Seniors, this is your last time you got to listen to me do this stuff. Please turn this in. Don't lose points for something that you just sat there and did with me. Seniors, all late work are due by Friday. CCP seniors, your exam's tomorrow. All CCP kids, your exam's tomorrow.
Is late work due by tomorrow night, or?
So please get your work in, and there you go.
Wait, what are we doing
Thank you.
tomorrow?
Tomorrow's the exam. So tomorrow you'll be working on the exam individually, quietly, acting like it's a test. No consulting with each other tomorrow in class or Monday in class. What you do on the weekend's your own business. But you got to show me work for every problem. That's the only thing. Okay? So please plan tomorrow to be working on it. If for some reason you're not here tomorrow, that is no excuse. It is still due for you at the end of class on Monday. I will look at, if you check in your Google, if you check in the Google stream of Google Classroom stream, I will post the password. So you'll have it even if you're not here. Anybody, you can look at it. Yeah.
I completely lost track of turning in the final reviews. I'm just turning in every picture I have for review 4.
Okay.